Looks like we've got some people out today. Okay, I only have one handout for you guys today, and I kind of messed up there on the numbering. It says that the number of this is 66, but actually 66 is just the front page. So 66 is the front and 67 will be the back. I just printed them that way to save a piece of paper. So the front will be the notes, and the back will be just a touch of practice for us. So I will update that on the agenda slide, but go ahead and just number the front of 66 and the back of 67, and then I'll try to remind you here later. Okay, so since we've been back from winter break, we did just a couple days of law of sines and law of cosines for you to hopefully get that right on the ACT. Then we have spent 2 days looking at limits, and the first day was trying to find the limit from a graph. So that is a good question type, and understanding the limit from the left and the limit from the right have to be the same for the other limit to exist. And it kind of helps us to check some of these other questions. But then on Friday, last time I saw you guys, we started talking about direct substitution and something called indeterminate form. So I'm going to give you a quick reminder of that and remind you of how we dealt with indeterminate form last class, and then show you a couple new ways to move forward, even though we're really trying to problem solve the same thing here. Okay, so if you don't have a graph and all you have is a function, then again, you should start off with direct substitution. So I'm sure I said that 50 times last period, but try to just plug it in, and if you get a real number, you can assume that that is your answer. That is what you hope to happen. And it does happen sometimes. Likewise on question 2, if you did direct substitution, you get 5 over 0, and since we cannot divide by 0, this would be undefined, so we would say that the limit does not exist. And then the problem we started to see last class was, well, if we just only rely on that and we try direct substitution, there's always a chance that your numerator goes to 0 and your denominator goes to 0. And 0 over 0 is unpredictable without more work. It's not just 0 because 0 divided by any other number is 0. Does not exist just because any other number divided by 0 would be 0. It's not necessarily 1 because you've got something divided by itself. We have to think of a way to rewrite this, make it look different without changing its size, and we need to fix it so that direct substitution does work. So this is the exact same thing we did on Friday, except on Friday, when we got 0 over 0, we always had questions that would factor. The numerator may factor, the denominator may factor, and then something would cancel. Notice that just doesn't work here. The numerator doesn't factor and the denominator doesn't factor. So the first of the 2 different types we're going to look at today is realizing that, especially when you have a square root like this, sometimes there's a thing called a conjugate that's going to help us move forward. So the thing that has a square root, I want to use the conjugate of that, and conjugate is just a fancy word that means change the middle sign. So if this is a minus, its conjugate would be a plus. And you have to make sure you multiply the same thing on top and the bottom, because now anything divided by itself is 1, so it's like I'm multiplying by 1, and that's what's keeping it from changing size. Okay, now when I multiply these fractions together, we know that when we multiply fractions, we will multiply the numerators together. So looks like we would need to start off with FOIL. But you can actually skip a little bit of that if you remember this about conjugates. And did we do conjugates at all last semester? I didn't think we did, but anytime you multiply something by its conjugate, you don't have to memorize this, but notice the outer part of FOIL and the inner part of FOIL always cancel. So if you know that, you can skip a little bit of your foiling process, but if you don't, you should see that in the next step. Okay, down here, if I say I've got an x minus 4 times a square root of x plus 2, I'm purposely not foiling those because my numerator is an x minus 4. So just like with factoring, I want this to I need something to cancel. So I need those x minus 4s to cancel, which is why I did not FOIL on the denominator. And just like with dealing with indeterminate form with factoring, as soon as you get something to cancel out from the numerator and the denominator, try to direct substitution again, and square root of 4 would be 2, plus 2 would be 4. Why is my answer to this not 4 though? Right. If your whole numerator goes away, it doesn't make your denominator your numerator. If your whole numerator goes away, it's a 1. So all of that is a 4th. Now, conjugates are by far not the most common math trick, but when we need them on a question like this, it's really the only way to move forward. As much as you may want to do factoring or something else, I honestly cannot think of a single algebra thing even more difficult than this that would work. So what you need to highlight about this is this. Multiplying the top and the bottom by the conjugate of the one that had the square root, doesn't necessarily have to be the numerator, is the one that just made it all kind of fall into place. Okay, so question 1 down here, that's the same question. I just did it up above, so we already have that one done. So that is one of the skills we're going to be looking at today. If direct substitution doesn't work and it looks like that, try multiplying by the conjugate. Okay, let's look at one more down here, and then we'll look at the other way we're going to look at today with indeterminate form. Okay, so question number 2 down here. Again, I always hope that direct substitution gives me a real number, because if it does, then I get to finish. So if I plug in 3 up here, I get 0. If I plug in 3 down here, what did I mean to do there? Okay, well, we'll just work it the way that it is. I plug in 0 into the top, I get 0. I plug 3 into the bottom, I get this. And as long as it's not 0 over 0, you don't have to do the fancy arithmetic to move forward. If it's 0 over some other number, it's just going to be 0. So I think I meant for that one to be another conjugate example, but it looks like direct substitution just worked just fine. So I guess I should slide back up. Any questions about this example up here? Y'all want to ask about? Okay. All right, then the other one we're going to look at today, because if I have you practice that 4 or 5 times, you're going to see what you need to do. You don't have to practice it 50 times before seeing how conjugate works. So the other one that we're going to look at today is sometimes trig identities are useful here. So same idea, same start, same end. All that's going to change is the creative way we rewrite this if it's indeterminate form. So if I try plugging in 0 here, the sign at 0 would be 0. By the way, in higher mathematics, we're always in radians. So this isn't 0 degrees, it's 0 radians, although it doesn't really change anything. If I plug in 0 down here times 2, you get 0, and the sign of 0 is still 0. So unfortunately, that one is indeterminate form. So we've got to think of a way to make this look different without changing its size. So as we move along throughout the next week or two, we're making a list of things to try. Direct substitution, hope that we're done. If it's not, factoring works sometimes. And then after today, after you practice it a few times, consider conjugates, and now consider trig identities. Now, to be fair, this first one's not a great example because you don't know this trig identity. This is called a double angle identity, and you will have to learn that someday when you get to Calculus 2 or to Cal BC, but we did not show that to you. But sine of 2x can be written as 2 sine x cosine x, but I'm using a trig identity there. And then just like with factoring, just like with conjugates, I need something from the numerator to cancel out something from the denominator. Not even write this. And then as soon as that happens, you can try direct substitution again. So the only thing left to plug into is right here, and the cosine at 0 is 1, so we get a half. So again, you didn't know that bottom identity, but I just made a substitution. I made it look different so that something canceled out. Okay, one more. And we'll flip over and let you try a couple. Alright, if I tried to plug in pi, so at pi, sine is 0, cosine is -1, so sine divided by cosine would be 0. Sine is 0, so it is indeterminate form. Again, I know most questions are rigged to be in indeterminate form, but don't skip that step. Okay, and then we look at this big mess of stuff. And if you remember when we did trig proofs last semester, it was really for questions like this. It's not that I care how you make this look, but you have to have some ideas and some practice and some strategies on how to make this look different. So hopefully, after a minute, you would say, well, we could make tangent be sine over cosine, because dividing by sine and multiplying by, or I'm sorry, dividing by cosine and multiplying by cosine, those just cancel. Okay, and then since something canceled, you could try direct substitution here. Although you could also cancel these and get 1, and the limit of a number is just going to be the number. But if you didn't know that one, then you could just plug it in, and at pi, sine is, oh, I lied. You do have to know that. If you plug this in, you still get 0 over 0. So that just means you need to do some more simplifying. But sine divided by sine is 1. Anything divided by itself is 1, as long as it's not 0 over 0. And then this was a property that I had on one of your first handouts, but we didn't really talk about it. All of this is just going to be a 1. So let me talk about why that is so that you can remember that. Remember, this is like the function, and when you have this, y equals a number, that's when you have a horizontal line. And so it doesn't really matter what x value you're approaching, it's going to be approaching that number from the left and that number from the right. So the limit of a constant is always just a constant. The limit of a number is a number, regardless of what x value it's approaching. But what I have highlighted right here is the important part. Thinking to rewrite tangent in a way so that something can cancel. Try direct substitution again. It wasn't enough. Get more to cancel. And then you can come out to your answer. Okay, so those are the two things we are going to try today. And I do want to remind you also about checking your work. So first off, I would like you to try, before you try any others, try question 1 and try question 6. That will be one of each. One of those is a conjugate type question, and one of them is a trig identity type question. So see how you do. I'll go over both of those with you to give you a little bit more feedback. I'll remind you on how you can check your answers with the calculator. There's not a ton of questions here, so you could realistically actually check all of them. But you can see we're going for quality over quantity here. Not a million practice questions, but we really need to give them our best effort. After you finish 1 and 6, if you're still waiting for everybody else, then of course go ahead and start working on some others. But Has everybody had time to try question 1? Okay. I have no idea what the answer is going to be. I was going to share the answer with you so that you would know if you needed to follow along or not, but it's okay. So you should have, even though I know it doesn't seem like it happens often, but that's because you don't need to practice a lot of these. But you need to start off with direct substitution first. See that your numerator goes to 0 and your denominator goes to 0. Then you start going through your list of ways to deal with 0 over 0. We're going to build this list up over the next week or two. But right now, all you have is factoring from last class, and then conjugates and trig identities from this class. So first off, this stuff doesn't factor, so that takes that off the table. There's no trig identities, so that takes that off the table. But honestly, it's because of this square root that gives me a big hint that it's going to be conjugates. And all a conjugate is you want the exact same thing, but you have to change the middle sign. Not also this sign, only the middle sign. Now I really want to multiply the numerator by that, but if I don't also multiply the denominator by the same thing, then it's like I'm not multiplying by 1, and I'm changing the size, and then whatever answer I get is to a different question. So that's the part you need to highlight and put a star by. That's the part, if you don't know that step, then there's nothing you can do to get past that. So, not to say that the other steps are easy, but they're at least steps that you have done in the past. So, multiply your fractions by multiplying your numerators together. Square root of 2x minus 5 times the square root of 2x minus 5 would be 2x minus 5. You can do the outer and then the inner if you want to, but as I mentioned a minute ago, with conjugates, the outer and inner always are going to cancel out anyway. And you need the last part of FOIL.
Can you explain how that was 2x minus 5?
This?
Yeah, the first one was 5.
Well, the square root of anything times the square root of itself is always going to be that. Like the square root of 3 times the square root of 3 is really the square root of 9, but that just reduces to 3. If they're both 5s, you get 25, but it reduces to 5. So if you've got the square root of something times the square root of the same thing, then you'll just always reduce to that thing. You got 2 of them, and square roots you need 2. Okay, and honestly, I forget this part sometimes, because even though I teach calculus, these type of questions don't come up that often. But it's tempting to FOIL your denominators as well. But if you do that, you're never going to see what needs to cancel. So you should have a step that gets you to here. Multiply by the conjugates, FOIL your numerators, don't FOIL your denominators. Now up top, minus 5 minus 1 is like a minus 6. And now we can pull in some stuff from last class as well. 2x and a 6 have a 2 in common. So if you factor out that GCF, now something is set up to cancel. Again, the only reason I knew that I needed to do that because I knew I needed something to cancel. And 2x minus 6 is a lot closer to x minus 3 than it is to that other mess. Now that something has canceled, I suspect direct substitution is going to finish the question. So try plugging it in again. We've got 2 on top. Plug in a 3 down here. This would be 6 minus 5 would be 1. The square root of 1 is 1. Plus 2 is 2. And 2 over 2 reduces to be 1. Now that we didn't end up with 0 over 0, we can assume that that is going to be our answer. Now, I know this is a little bit more time consuming, but again, we're not giving you a ton of questions here, but there's a good way for you to check your answers. And I would do this on most of these, if not all of them. But if you look at that big thing at the start that we were trying to find the limit of, if you ask your calculator to graph it, then you can just ask yourself, well, what is the limit visually? This was the first thing that we did. And as x approaches 3, it looks like a little bit to the right of that, it's around 1. As it looks like it's getting closer to 1 from the right side, and from the left side it looks like it's getting closer to 1. And if it's approaching 1 on the left and 1 on the right, then 1 is its limit. So if you're willing to graph this, you can do the visual check, which was the very first limit process that we had started. Okay, let me leave this up for a minute so that you guys can see if there's any follow-up questions you'd like to ask, anything about why I did something or how did I know to do something. And then I'll give you a little bit more time to try question 6 before we go over that one. And then you'll be on your own for the rest unless you have specific questions. Any follow-up to this number 1? All right, let me give you a few more minutes before I expect you to have an idea of what to do with 6. I want you to try it and see what you do, but okay. Let me go over number 6 with you to help you see where that answer should have come from. So again, please don't assume that they're all indeterminate form. Especially when we get to our test, there will be a few that may look like they are, but if you actually plug them in, they're not. So at 0, cosine is 1, so the numerator goes to 0. At 0, sine is 0, square is 0, you still get 0. Multiply that by 2, you still get 0. So this one is indeterminate form. So mentally, I'm going through my list of things. I want to pick off the one that seems the easiest. So far we've got factoring. I don't see anything that factors. We now have conjugates. Conjugates work when you have like a square root. No square roots in here. And trig identities. So I don't recognize the numerator to be a trig identity. But right here, we can make a substitution for sine squared. So since sine squared plus cosine squared is 1, instead of saying sine squared, we could say 1 minus cosine squared. Again, that's very similar to the trig proofs that we did last semester. Last semester we had a goal for you, make it look this certain way. In this one, it's not that you have to make it a certain way, but again, that's not that intuitive. When you look at this, I suspect there's not more than 1 or 2 people that thought to change that to 1 minus cosine squared. But that's where you need some practice with that. Okay, so nothing's canceled out. So I know this is still indeterminate form. I'm not going to start plugging it back in yet. Now, you might be tempted to try to make these ones cancel or to make some of these cosines cancel, but that's not how fractions work. You can't cancel out terms, things being added or subtracted. So, did anybody get to this point and then have an idea of what to do next? Okay, so to me, this guy, again, not super obvious, but I do have a hint that I need to cancel out some of the numerator or all the numerator. This guy is the difference of two squares. You've got one being squared on the left and cosine being squared on the right. So you can factor that. And again, your hint is you knew something needed to cancel, so somehow some of that was supposed to become a 1 minus cosine. And now that something has canceled, try plugging it in. Looks like we get a fourth. And a fourth is a real number, so I suspect that that would be my answer. But we can also take just a second to graph it in our calculator and make sure that it looks correct. I will add though that when you graph this type of stuff, you better make sure that your calculator is in radian mode. Sometimes you might get lucky, but pretty much all higher mathematics is in radians. You should always assume you're in radians in higher mathematics. So if I graph this, again, I don't really care what's going on with this graph, except for what y value is it approaching as x approaches 0. So if you go to 0, it's not going to exist. We're not trying to get a point here. That's not what a limit's about. It doesn't care that x equals 0 doesn't exist. But then if you cursor just a touch to the left, you can see as x gets really close to the left, it looks like the y value is getting close to a fourth. And then if you move your cursor to the right of 0, so x is almost 0 on the right side, it looks like y value is also approaching a fourth. And if it's approaching a fourth from the left and the right, then that just confirmed that that was correct. Again, don't use the graph as an answer getting strategy because you're going to be setting yourself up poorly for the test, but certainly a good way to check. If you got a different answer, or maybe if you got halfway through the question, sometimes knowing the answer would help get you kind of unstuck. Alright, so to be fair, there is not a ton of trig proof or trig limits on here. Just those questions are a little bit harder to come by. So quite a few more of the conjugate questions, but it looks like you should only have 5 more total. So anything that jumps out at you about number 6? Yeah.
How did you type in sine squared x on the calculator?
You have to just say, you have to do sine x and then put the square out here. Calculators don't let us put it right here how we normally write it, so just make sure that you don't do it like this, because then it wants to square the angle and not square the sine. That would mean something different. Okay, so as you guys work through here, again, please check some of your answers, especially if you feel shaky about your final answer. And then if you're not getting the right answer and you're not sure what you did wrong or you're getting stuck, then I would be happy to help. But the rest of these you need to, unfortunately, you just have to struggle through them a little bit. You got to kind of see what roadblocks you're personally going to have. And again, factoring that we did last time is by far the most common, but these are also common limit questions. And in addition to learning a little bit about limits and how to deal with limits and knowing what indeterminate form and all that stuff is, this stuff is good algebra practice because conjugates are good for lots of things, not just limits. Factoring is great for lots of things, not just limits. Trig identities, same thing. So really the practice that you're getting in is for more than limits. It's just that we're focused on limits questions right now. Okay, go ahead and speak up when you would like me to help out. Otherwise, I'll check in once in a while with y'all.
What would you do on this one when you get to this part?
I would combine your like terms here, so that'll give you minus 16,
Oh, okay.
and then 4x and a 16. You could factor out a GCF of 4.
And then you could cancel that
Yeah,
out.
and then that'll cancel that out.
I'm getting to here on all of them, and now I don't know what to do.
Combine those like terms. Call that -6. Now you can factor out a GCF of 3. Three
X
times.
minus.
Yep.
Can I cancel that? But I don't know what to do. I'm getting that on all of them.
When you foiled these two,
Mm-hmm.
-2 times +2 would be,
-4.
okay.
Oh, I guess I did that on all of them then.
Well, that's easy fix at least. But then that makes that +1, which then cancels.
Okay, so yeah.
Okay. Is anybody completely stuck on one that you would like me to go over with you?
Can you do 5?
5, sure. Let's see. So plugging in 2 certainly makes the numerator go to 0. Plugging in 2 to the denominator would give me 6 plus 5, also 0. So this one is indeterminate form. So going down my list of things to try, doesn't factor, and then our new things today, conjugates and trig identities, certainly looks more like a conjugate question to me than a trig identity question. Now, you don't always want the conjugate of the numerator, you always want the conjugate of the part that has the square root piece. So I would like the conjugate of the denominator this time. Better multiply the same thing on top and bottom, so it's like you're really multiplying by 1. You still okay up to there? Okay. So in the numerator, I'm just going to say I've got x minus 2 times this, because I suspect this x minus 2 is going to cancel out. But in my denominator, I need to FOIL these two terms with these two terms. When you multiply your fractions, you multiply your denominators, 2 terms times 2 terms. You can refer to FOIL if you want to. So, first part of FOIL, 1 times 1. I know the outer part of FOIL and the inner part of FOIL are going to cancel anyway, so I'm going to skip that. And then right here might be your mistake. But the square root of 3x minus 5 times the square root of 3x minus 5 would be 3x minus 5. But a positive times a negative means that this is negative. Not that 3x is negative, the whole thing is negative. A negative something times a positive something gives you the negative something. So if you only attach the negative to the 3x, then you're going to get stuck. So I would suspect that would be a common mistake there. Minus 5. Okay, down here I've got 1. I could distribute this negative. I could combine 1 and plus 5 to get plus 6. And then I know this needs to look something like this. So if I was to factor out a -3, do a GCF, now something cancels, the x minus 2's. And then I can probably finish with direct substitution now. Plugging in a 2 up here gives me 1 added to this one. Try to plug 2 in down here, but there's no x's left over to plug it into. So it looks like -2/3. So was it this, the negative?
Yeah.
Yeah. Yeah, especially when it's, I mean, I know that you guys know a positive times a negative is negative, but when there's more than one term, you have to make sure it goes to all of the terms. Let me give y'all a little bit longer before I ask for another question. Again, I know you guys are going to get sick of me saying this, but it's one of the most important points I need to make over the next few weeks. This is exactly why calculus can be difficult. The idea of the limit and what you're finding and the calculus steps here are never what anyone asks for help on. It's always the trig and the algebra that makes calculus hard. Conjugates are an algebra topic. Multiplying fractions, even before algebra, I guess with x's and stuff in there, it's an algebra topic. Factoring GCFs and seeing the factor GCFs and carefully multiplying positive times a negative and making sure that it goes to both. And longer questions like these are very common in calculus. Longer a question is, the more likely you are to have a careless mistake at some point. You got to get a lot more right. You got to be a lot more consistent for your final answer to be correct. But that's the way it goes. Anytime you guys hear anyone complain about calculus being difficult, it's always, always because of the algebra, the trig, the unit circle, stuff that you've seen and have learned in the past, but trying to pull it all together without hints, without the hint of GCF, all that kind of stuff just is a whole nother level. So. Okay, let me give you a little bit longer and then I'll ask for another one on the board. But honestly, each question we do should help with other questions as well. They should be pretty similar. Has anybody found another one that you're having trouble with? Yeah.
Can we do 7?
7? Sure. Okay, so if we start off with direct substitution, at pi over 2, cosine is 0. Square 0, you still get 0. Multiply by 3, you still get 0. In the bottom, sine of pi over 2 is 1. So you end up with 2 minus 2, which is also 0. So this is, in fact, what we refer to as indeterminate form, which is the only type of question you have to dig in deeper. So my first method that I know is factoring. The numerator doesn't look like it factors, but the denominator has a GCF, so you could factor out a 2. That's not enough, though, to get anything to cancel. So I'm done with factoring. Nothing else factors. This doesn't look like a conjugate question, so it must be some sort of trig identity. I don't have any trig identities I could plug in here, but instead of saying cosine squared, we could use our first Pythagorean identity and instead say 1 minus sine squared. Okay, and then again, I know I want something to cancel, and I know these look similar, but they can't cancel out as is. You can't cancel out terms, things being added or subtracted. You can only cancel out factors, things that are being multiplied. So the one extra thing you got to do, similar to the other one we did, is realize that even after you did that identity, this is the difference of 2 squares. You've got 1 being squared on the left, you've got sine being squared on the right. Difference of 2 squares always factors as a plus and a minus. So after all of that, finally 1 minus sine x will cancel out in the numerator and the denominator. And I'm probably doing too much in one step. It's getting kind of messy, so I'm going to rewrite what I have left over. But since something has canceled, 99% chance that direct substitution is ready to go now. So plug it into what you have left over. This would be 1. At pi over 2, sine is 1. So 2 times 3 would be 6. Divided in half should be 3. I think in the end, all of that would come out to be 3. But the most important part to this question was realizing you could change cosine squared into 1 minus sine squared, and then seeing that you could factor 1 minus sine squared with the difference of 2 squares. Okay, was that enough for 7? Okay. All right, let me leave that up in case anyone's still working with it. Looks like I'll have time to check back and answer maybe one more with you guys. I know you don't have a ton of questions, but you may need to bring it up here and have me look at it if you're struggling more than that. Sorry, I do need to distract you here for a minute. I forgot that you guys will be doing CAP all week this week. There will be no advisory movement. I think Friday is a pep rally, but Monday through Thursday is getting you signed up for classes. So of course, if you are a senior, it doesn't apply quite as much to you. But these are the fourth year math courses that we offer. And I like to present it to you in this way because there are some courses that you guys just don't hear about very much for one reason or another. So you guys are currently in pre-calculus. So of course my recommendation for most of you would be to do AP Calculus. That was kind of the point of learning all that trig and now learning a little bit of calculus, and we'll finish the year with all the algebra that you need to know. But there's some other good choices as well. So I'd say Algebra 3 is probably an easier course than this overall, just how demanding it is and how much homework and stuff that there is. But Algebra 3 is a great one to prepare you for college algebra. If you think that you don't need calculus, you're not interested in calculus, but you don't think that maybe your algebras, you're not comfortable with it being prepared for college algebra. We do have some students who double up in this. Like they take Algebra 3 and College Algebra first semester, and then College Algebra is just a one semester course. So if someone passes College Algebra, then they usually drop Algebra 3 at semester. But it gives you a little bit of a safety net there. But after College Algebra, since it's a one semester course, you can also either sign up for finite, which is just very different. Some probability, some other stuff. I don't know how true this is anymore, but when I went to the university here in town, regardless of what you were majoring in, if you were an art major, they required you to at least have college algebra and finite math. That was like the minimal math that you had to have. So I think one mistake that students make that do take college algebra is they do college algebra and then they don't take finite when they're at high school. And especially if that's all the math that you're going to need, you might as well get it out of the way. I don't think that this should dictate your decisions or anything, but I did recently just pick up one of these like quick study things about finite, and it kind of just shows you like the different units of study. There's like some logic and some matrices and applications, probability, stuff like that. So if you're interested in kind of what finite is because you think you're going to take it, you're welcome to flip through this anytime the rest of the year. I'll leave it up there. It's not terribly difficult. It's just different than what you've done in the past. I would also push for, I know your schedules are all pretty full with stuff that you want to do, but if you do take college algebra, I'd also suggest maybe trying to follow it up with college trig. College trig is not much more difficult than what we did first semester. Knowing the unit circle, knowing the identities, knowing what sine and cosine graphs look like. Not that our first semester is easy at all, but when you are basically redoing that stuff and going just a little bit deeper, that would be pretty easy college credit. But so for most of you, I would pick Cal AB. If it's not that, I would be considering college algebra or AP Stat. And if you're going the college algebra route, remember that it's just one semester and you may want to follow it up with others. Are there any of these courses that you're more interested in? If you want to know more details about? You guys know what you want to sign up for next year? Okay, because there's a lot of these courses, like I don't know that much about them, but there are some follow-up slides. Of course, your CAP book is going to talk quite a bit about some of the stuff. But also, if there's some of these you want more information on, Miss Rogers is like our college algebra teacher this year, and I've got the room number down here, 2704. So if you needed to ask her specific questions about it, questions you think I might not know. So all of these are very detailed if I click on them. Any others you'd be interested in? I can't speak too much on AP Stat. I know some students like that. My only concern with AP Stat is if you guys decide to do calculus later on, it's usually good to do it right after pre-calculus. Taking a year or two off of the trig and the algebra, because AP Stat is way different. There's a lot more writing. You write a paragraph to justify your answer. A lot less like step 1, step 2, step 3, a lot less procedural stuff. Okay, last chance. No other questions about signing up for math classes next year? Okay, if you think of anything, then please ask. It's much better to ask than you guys sign up for something and then realize this isn't what you thought it was going to be, or it's not good for where you're trying to go, or what you need, all that kind of stuff. The one extra thing I'll add about college algebra, and I don't know how true this is for all universities, I don't know if it's true anymore, so I'm not telling you it as fact, but I know the U of A, as of a year or two ago, if you had a 26 or higher on your math ACT, it would automatically give you college algebra credit. So if you have around a 26 or higher in math and you were thinking of college algebra, you might do a quick Google search for some of the schools you think you might go to and see if they're going to give you the college algebra credit, because there's no point in you paying for it. And now it doesn't cost much, but you do have to pay for it because it's a college class, and it does affect your GPA and all that kind of stuff. So I would hate for you to do all that work and then find out that it was completely unnecessary. So I think there's also a number where you might be able to get finite credit as well. That might be like 28 on the math ACT. But again, I can't speak for all schools, and I don't know if it's even true anymore, but as of a couple years ago, they did give credit for 26 or higher. Okay, you guys got about 10 more minutes on today's worksheet, so please make sure that if you don't have time to finish that in class, that you do finish that before Thursday. If you're getting stuck on any question, you still got 10 minutes, so feel free to bring it up here and let me help you. Let me help point out what you may not be looking at. Otherwise, that's it for today.
Are we trying the back of the page that we did last time, like 65?
We will, just not today.
Okay.
No. I'm just used to taking up assignments on quiz or test days, but in this unit I'm going to have to pick them up sometime sooner, just because we're going to be here a couple weeks, so it'll be too much to turn in at once.
Bye.